Okay. So whatever we have done till now, based on that we will do some questions. Look at this. First question. An ideal compiler should be. An ideal compiler should be. Option A. Option A. Small in size. B. Takes less time for compilation. C. Must produce an object code. Must produce an object code which executes faster. And D. D I forgot. So you just fill this D option. Okay, I forgot this. You just got it. So an ideal compiler should be small in size, takes less time for compilation, must produce an object code which executes faster, and what is D? Okay, just tell me ideal compiler, the best compiler. Okay, what is the answer? So what should be? What should be the D option? If it is MCQ, multiple choice question, what should be the D option? Yeah, it's good. Okay. So whenever you are designing a compiler, it must be small in size, occupies less memory. Okay, takes less time for compilation, it should be faster. Okay, and must produce an object code, whatever the result, that output should be executed faster. So we required all of these. We required all of these. So all is the answer. All is the answer. It's a simple question. Okay. Next. In a compiler, the keywords of a language, are recognized during A. Lexical analysis, B. Syntax analysis, C. Semantic analysis, and D. All. Whenever you are giving the answer, you just mention the question number, then give the answer. If you say all, so what should I understand? That all is for first question or second question? Because there is a lag between you and me. Almost 2 minutes lag is there. Okay. In a compiler, the keywords, I told you in the lexical analysis, the lexical analysis scans every character of the source code and divides into tokens. The tokens can be a keywords or operator, or it can be a constant, or it can be a special symbol punctuation mark, or it can be an identifier. So whether it is a keyword or an operator or anything, that will be recognized during lexical analysis phase. Lexical analysis phase. Okay. Next, a link editor. A link editor is a program. A link editor or a linker. Yesterday I told you, linker links all the modules into single module at the time of execution. Okay. So you have to link all the modules as a single module, and also it resolves the external references. Now, okay, see, a link editor is a program that matches the parameters of macro definition with the locations of the macro call. So macro definition, macro call, these all will be done before compilation. That will be done by preprocessor. So it is not a part of link editor. It is not a part of link editor. Next, matches the external names of one program with locations in another program. It is called as external reference. External reference. The external references will be resolved by link editor and acts as a link between the text editor and user. No, it's not. Then it is not all. So go for option B. Okay, next. Next. In a compiler, the data structure used to manage the information about the variables and their attributes. About the variables and their attributes. Is abstract syntax tree, semantic tree, C, symbol table, D, opcode table. So which one is the answer? Okay, this is semantic stack. So what is the answer? Good, symbol table. Good. It's a direct question, direct answer. Good. It is symbol table. Next. Next question. Have you copied this question? In a compiler, the module that checks every character of the source code is dash. Question 3. This is the third question. I think you are late. This is the third question. A link editor is a program. In a compiler, the module that checks every character, so that checks every character of the source code will be read or scanned by the lexical analyzer. So the other name of the lexical analyzer is scanner. This is lexical analysis. Okay, next. The system program that sets up an executable program in main memory which is ready for execution is option A, linker, option B, assembler, option C, compiler, D, none. Why are you asking about the question matches the parameters of macro definition with locations of macro call? So this is done by what? Pre-processing. Macro expansion will be done by pre-processing, not by link editing. Okay, it is not by link editor. Link editor is called linker. The system program that loads an executable program in main memory and it makes the initiation of the execution of the program by loader. So answer here it should be loader. So in the place of none, actual none is the answer. If you want the perfect answer, it should be loader. Okay. Okay, good. Now, an instruction in a programming language that is replaced by sequence of instructions prior to compiling is known as literal label macro procedure. Okay, so these are all the basic definitions of whatever we have discussed till now. Anybody answer? So, an instruction in a programming language that is replaced by sequence of instruction prior to compiling. So, sequence of instructions we can replace with one instruction, that is macro name. So, answer for this is macro. Okay. Next question. Which of the following is used for grouping of characters into tokens? Parser, B. Scanner, C. Code generator, D. All. Which of the following is used for grouping of characters into tokens? So, grouping of characters into tokens. Okay, the lexical analyzer scans every character of the source code. So, example, int x comma y is there. So, this group of characters into one token, which is keyword, and this is one token. So, group of characters into tokens will be done by lexical analyzer. The other name of the lexical analyzer is scanner. It is done by lexical analyzer. The other name of the lexical analyzer is scanner. Next. Which of the following is the function of a loader? A. Allocation, allocation, tokenization, relocation, D. Loading. Which of the following is the function of a loader? It's a direct question. No need to explain more about this question. Okay? Got it? Which of the following is the function of a loader? So, allocation, it allocates the required space. Relocation, it alters the address with different locations if it is not available. And loading, finally, it loads the program into the specified location in the main memory. So, allocation, relocation, loading, and tokenization is the part of lexical analysis. It is by compiler. Okay. Now, so these are the A, C, D are the options for 9th question. Okay, guys. Some of you have given only C, only D. So why not A, C, D? Huh? Okay, that's all. We'll go for next topic, next new chapter. This is the subject. Okay. We have done this part. Basics of compile we have done. Now, I am going to start lexical analysis, new topic. It will be done in 2-3 hours. Then we will go for syntax analysis. So, after finishing this second topic, you can do the workbook. I already requested the concerned team to upload the workbook. Most probably today or tomorrow they will upload the workbook. Okay, and then you can do the first and 1 and 2 topics. The first chapter in the comparison, first chapter is given based on this 1 and 2. Here I wrote this is the first workbook, first chapter workbook. You can do. So you try your own, and meanwhile tomorrow I will upload that. Tomorrow evening or day after tomorrow, I will upload that workbook solutions. So before watching that video, don't go for directly a video. You just try all the questions yourself. Okay, that you will understand how knowledge you are getting, how you able to do you can do the questions. Okay, so first you try yourself, then you watch the video. If you are not getting still, if you have any doubts, you can ask me in the class. Okay, so now I am going to start this. Lexical analysis. This is easy topic. Give me just 1 minute time. I will come back in 1 minute. Okay. So, lexical analysis, I told you in the phase of compiler, every character of the source code will be scanned. Every character of the source code will be scanned by the lexical analyzer and the following will be done. So, what did I say earlier? Only it divides it into tokens. Only the part which I explained earlier was it divides, it scans the source code, it reads the source code and divides it into tokens. Not only divides into tokens, so what happens completely we will see now. Okay. So, take the notes, every one of you please take the notes. The lexical analyzer scans every character of the source code. The lexical analyzer scans every character of the source code The lexical analyzer scans every character of the source code and the following will be done, and the following will following following will be done by it. Following will be done by it. Divides it into tokens. Divides it into tokens. Ignores, just you copy, ignores comments. I will explain in detail about every function. Divides it into tokens, ignores comments, ignores white space characters, such as blank space, tab space, blank space, tab space, and new line characters. Okay, and new line characters. Okay, you just copy this one. We thought MCQ, so what happens with this? Okay, MCQ, then it is not Abhay Kumar. Okay, so divides it into tokens, ignores comments, ignores white spaces, then it counts the number of lines, in the source program, it creates a symbol table. It creates a symbol table. It produces lexical errors with line number and column number, if any. Means if any errors are there, then only it will produces. Next, it interacts with syntax analyzer. Okay, you just copy. I will explain each and every point one by one. If anybody has missed the yesterday's class, please go to the recorded version. it's easy. So whatever we have discussed till now, so by watching the videos you can understand. So you don't you have not missed much anything. But now onwards, especially for the second topic, the third topic, syntax analysis onwards, you should not miss any of my classes. Okay. So the continuation will be there. If you miss any of my next classes, so it is difficult to follow the next topic. So every topic will be depends on the previous topic, especially for syntax analysis chapter. Okay. Guys, copied. Okay. Now, so I will explain one by one. It interacts with symbol table. It interacts with symbol table. Lexical analysis, syntax analysis, token, request for next token, source code, parse tree. Just copy this, guys. Copy this. So of course they will be interacted with the symbol table also. Symbol table will be there. This is symbol table. Symbol table. So every phase Copied? Okay. Now, it interacts with the syntax analyzer. Whatever the source code will be given to the lexical analyzer, it is the first phase of the compiler. It scans every character of the source code. It produces the token. The token will be given to the syntax analyzer. The syntax analyzer will check for the syntax of the statement. According to the rules of the grammar, quantity free grammar, we will discuss later. According to the rules of the grammar, if it is satisfying the proper syntax, every language will have its own syntax. So, whatever the tokens produced, if they are properly satisfying the syntax of that language, then it will construct a parse tree. Then the syntax analyzer will request the lexical analyzer to produce the next token. I repeat this. The lexical analyzer scans the source code and it will produce the token. The syntax analyzer will check for the syntax of the token. If it is well formed, it will construct a parse tree. Then the syntax analyzer will send a request for the next token. Until the syntax analyzer send the request for next token, the lexical analyzer will not produce the token. Actually, lexical, syntax, semantic, these all simultaneously work together. So, token, then syntax analysis, okay, then parse tree, then meaning of the parse tree, then again come back. So, next token, then for parse tree, then meaning of statement. So, all will be work together, okay, and simultaneously they can interact with the symbol table. The information will be fetched from the symbol table whenever it is necessary, okay. Now, my question is, why should we separate lexical, syntax as a different modules? That is to simplify the design of the compiler. Why? Suppose one big project is given to only one person, okay, and the same project, if it is given to among 4 people or 5 people, the thing is, so the project will be simplified. If the project is divided into 4 modules and give the one module to one person, then he will efficiently can perform. If the same person has to do all the modules, okay. And one more thing, actually in lexical analysis, the program we use is finite automata. In lexical analysis, the program we use is finite automata. Actually, the tokens here we have seen, it divides into tokens. Already in the phase of compile we have seen. The tokens will be produced by lexical analyzer. For those tokens we write the regular expression. For the regular expression we construct the finite automata. That finite automata will be used in lexical analysis, okay. And in syntax analysis, the program used is push down automata. In syntax analysis, the program used is push down automata. Of course, the finite automata cannot do the job of PDA. It cannot do the job of PDA. Of course, some languages it can accept. So, whatever accepted by finite automata also be done by push down automata. It is next level of the machine. But whatever the PDA can do, it will not be done by finite automata. So, this, even though if anybody has option for the TOC, you don't bother about this one, okay. This again it will be repeated after once the cycle is completed, TOC also will be done to you. So, simply remember the lexical analysis, the program used in lexical analysis finite automata, the program we use in syntax analysis push down automata. So, instead of separating lexical analysis and syntax analysis, we can use only one module that we do tokens and then parsing. So with the help of PDA we can do. But so here the burden, so as one project is given one person, if the same project is given to multiple persons, so the burden on one person will be more, whereas if it is divided into multiple persons, so here the design will be simple, efficiency will be more. So that is the advantage of separating lexical and syntax analysis. So it makes the design of compiler easy, that design will be simple and efficiency will be more, and portability of the compiler, the reusability of the compiler will be increased, portability of the compiler will be increased. These are the advantages of separating lexical and syntax analysis. Okay, so design will be simple and efficiency will be more, portability will be more when you design when you separate the lexical analysis from the syntax analysis phase. Okay, so I'll give you the notes. This first part we have done. So I repeat this: the lexical analyzer produces a token. For that token, the syntax analyzer checks the syntax. If it is well formed, it considers a parse tree. That parse tree will be given to the semantic analysis phase, and it requests for the next token. Until you get the request from the next token, the lexical analyzer will not produce the next token. Okay, then, and the program used in lexical analysis is finite automata, and the program used in syntax analysis push down automata. So push down automata can do the part of lexical and syntax also. So instead of doing separately, if we merge, then burden on PDA will become more. So to make the design simple and to increase the efficiency, to increase the portability of the compiler, if we separate, then it will be more advantage. Okay, so take the notes. Take the notes, copy this one. This is parse tree. Take the notes. Why should we separate lexical analysis from syntax analysis? Why should we separate lexical analysis from syntax analysis? Take the heading: why should we separate lexical analysis from syntax analysis? First point. To simplify the design of a compiler. To simplify the design of a compiler. To simplify the design of a compiler. Second point. I repeat the first point. To simplify the design of a compiler. Second point. To increase the efficiency of a compiler. To increase the efficiency of a compiler. Third point. To increase the portability. to increase the INC, increase the portability, within brackets, portability within brackets, reusability. To increase the portability of a compiler. To increase the portability of a compiler. Okay, next. So the last one is done. Now divides it into tokens. It scans every character, many times I told you, and it divides it into tokens. So here the terminologies we use in lexical analysis are token, pattern, lexeme. Somebody has asked what is low token, pattern, lexeme about this yesterday. Okay, that time I didn't respond. So token. So take the notes. The terminologies we use in lexical analysis. The terminologies we use in lexical analysis are token, take token. The token tells you the category of the, it describes the category of the input string. It describes the category of the input string. It describes the category of the input string. That means what kind of token it is. Is it a keyword? Is it an operator? Is it a constant? Is it a special symbol, punctuation mark? Or if it is none of these, then it could be an identifier. If it is not a keyword, if it is not a keyword, if it is not an operator, if it is not a constant, if it is not a punctuation mark, then it can be an identifier. Don't think that whatever the scanned group of characters does not comes under these categories, then it will be a identifier. No. I repeat, if the group of characters is not a keyword, not an operator, not a punctuation mark, not a constant, then it may be or may not be an identifier. So compare is completely language dependent. If you talk about C language, okay, so there are some rules about the identifier. What is an identifier? What are the rules for identifier? Okay. In general, an identifier is alphanumeric symbols. In general, an identifier is alphanumeric symbols, and only special symbol allowed is underscore. In identifier, whenever you are defining and giving a name to any variable, you can name it using alphabets, numericals, and both combinations of alpha numerics, and also only special symbol is underscore. Only underscore is allowed, and the first symbol of the identifier, it should be alphabet or underscore. I can say A1, it is a valid. If I say 1A, it is not a valid identifier. At the same time, underscore A, it is a valid. So the first symbol can be an alphabet or underscore, but the first symbol cannot be a numerical value. Okay? Then using according to the rules of identifier, an identifier can be any combination of alphanumeric symbols. Only special symbol allowed is underscore. Okay, and the first underscore you can use underscore and alphabets and numerical combination, any combination any number of times, but the first symbol must be either alphabet or underscore. If you are using the first symbol as a numerical, it is not a valid identifier. So every language has its own rules, and this is general for C language. Okay, now, so what is token? It describes the category of the input string. Now, so take the terminologies used in the lexical analysis are first token, copy this, it describes. Okay, done. I am not giving the notes for this what is identifier. So you just write a running notes. Okay. Now, a token is a pair. A token is a pair consists of token name and attribute value. So what is this attribute value? It is an optional. A token will contains, it is a pair consists of token name and optional attribute value. What is an attribute value? It is a pointer which points an entry of that variable in the symbol table. Okay. So when I tell you example, after finishing this with example, I will tell you what is a token, what is lexeme. Okay. So it is a pair consists of token name and attribute value. Attribute value is an optional. It is a pointer which points the entry of the variable in the symbol table. Okay. So take these notes. Token is a pair. PM punctuation mark. Okay. So take token is a pair consists of copy this one. Consists of token name, attribute value. Token name and attribute value. Next. Continue. Next line. Attribute value is optional. Attribute value is optional. Attribute value is optional. Continue. It is a pointer. Which points to the entry of the identifier in symbol table in the symbol table. Okay. Next. Pattern. The set of rules which describes the tokens. The set of rules which describe the tokens means what are the rules? What are the rules for keyword? What are the rules for operator? What are the rules for identifier? What are the rules for constant, punctuation mark? All these will be described in pattern. So the set of rules which describe the token. Okay. So or you can say the set of rules which describe the define the or set of rules to define the regular expression. You can write like this also. The set of rules to define a regular expression. Both are same. The set of rules to define a regular expression. So what are the rules for different tokens? What are the rules for keyword? What are the rules for operators? So I told you, keyword, operator, constant, punctuation mark, identifier. So there are rules for everything. So what are the rules? Those will be defined in pattern. Next, lexeme, the sequence of characters in the source program that matched with the pattern of the tokens. Just you copy this one, you will with example you will understand. Okay, I am giving you one example. A equal to B plus C into 2. Okay, now, so what is a lexeme and what is a token? What is a lexeme and what is a token? We will see now. Pattern is rules, that rules. Okay. Now, there will be a symbol table. Now, look at this, guys. A is a lexeme. What type of token it is? It is an identifier. It is a token name. Token consists of, okay, a pair consists of token name. What is this A? It is a identifier and attribute value. So it is a pointer. I am taking as a points. First one, it is a pointer which points to the entry. So what is the token here? What is the lexeme? A is a variable, and it is one is its attribute value. This one points to the entry of the A in the symbol table. So its information will be available here. Okay, that is. Or you can simply we write ID1. As in the case of previous phases of compiler, A equal to B plus C star 10, I wrote, you remember, ID1, ID2, ID3 like that. Okay, and this is lexeme. And what is this? It is an operator. For operators, we don't store anything in the symbol table. Okay, now this is a lexeme. And what is its? It is an identifier. And let this entry is 2. So in the 2, so B will be there and its information. Okay, or simply you can write ID2. So here lexemes are A and equal to and B and plus and C and multiplication and 2. So here next plus is an operator, so you don't have any attribute value. It won't have any attribute value. Next, so this is done. Then next C is an lexeme. It is identifier and let its attribute value is 3. So or simply we can write ID3. So this is C. Okay, and next it is an operator. And 2, it is a constant. So lexemes and tokens. Okay, so copy this one. Today we will complete the lexical analysis topic, and also I start the syntax analysis. In syntax analysis, I will complete context free grammar the basic definition. So whatever required for this subject, that part I will take care of it, because some of you are newly joined. So for your purpose and to make it easy, I will tell you what is grammar, what is quantity free grammar. Then I will go for ambiguity, left recursion, left factor. So now onwards, don't miss any of my classes. Okay, next. Done? Now, next one. Tokens will be recognition of tokens. Recognition of tokens. Next heading. Tokens will be recognized by finite automata using regular expressions. Tokens will be recognized by finite automata using regular expressions. Copy this one. Tokens will be recognized by finite automata using regular expression. Okay. So you can take it as a note. The program used in lexical analysis is finite automata, FA, that is finite automata. The program used in lexical analysis is finite automata. Okay, just look at this, guys. Whoever in the class who doesn't know anything about the TOC, the finite automata, you just leave it. Don't bother about this one. Just look at this. So first, tokens will be constructed. For the tokens, regular expression will be constructed. Regular expression for tokens. Okay. Regular expression. So whenever you have the regular expression, so the best finite automata is minimized DFA, deterministic finite automata. For every regular expression, it is not possible to construct the DFA directly, minimize DFA directly. Okay, and sometimes we can consider DFA first. From the DFA, we can convert into minimized DFA. And even for some regular expressions, we cannot consider DFA directly. Example, I will give you A star plus B star, A star B plus B star A. So directly you cannot consider the DFA. You may not. Some of you may not. So, but we can consider N of A simply. N of A. Even for some expressions, it is difficult to consider N of A also. Example, this one. So, for whatever I am not saying that this is the sequence. So, for some expressions you can consider directly minimize DFA, and suppose if I give you A plus B whole star, anyone can consider directly, this is A plus B whole star. It is a minimized DFA. And if it is more complicated, then you can consider only DFA. If it is even more, then NFA. If it is even more, then NFA with epsilon moves. So whatever the regular expression is given, for any regular expression, even though it is more complicated, you can construct NFA with epsilon moves. NFA with epsilon moves. So, suppose a regular expression is it is more complicated, but you can consider NFA with epsilon moves. Then we have an algorithm which we can convert NFA with epsilon moves to without epsilon moves. So, using that procedure, that algorithm, we can construct an NFA without epsilon moves to the equivalent NFA with epsilon moves. This is the part of TOC. So, you will see, okay, when your TOC comes, okay, the absentees or late joiners, you do not bother about this one. Okay. Now, when you have NFA to DFA, there is an algorithm. So, we can convert every NFA into DFA. Algorithm is there, and if you have DFA and that DFA we can reduce the number of states, there is a algorithm. So, we can go for minimized DFA. So, whenever tokens are generated and those tokens will be accepted by minimized DFA by writing the regular expression. Okay. This is the hand code design. You just copy this one, copy. What is regular expression? You are absent. I think you joined late, okay, recently. So, just leave it, okay. Whatever possible we will see, and the more you can see in the TOC subject. So, even though you do not know about this one, it is not at all much important for this subject. Okay. This is Sushmita. Okay. Now, okay, somebody asked me what is a regular expression. Recognition of identifiers. Recognition of identifiers. Look at this. An identifier, generally it is a combination of, what is an identifier? Combination of alphanumeric symbols, and also it can be the special symbol can be used is underscore. So, an identifier can be any combination of alphabets, numericals and also underscore, but the first symbol must be either alphabet, that is letter, or underscore. So, I take L. L is stands for letter. A letter can be a small letter A, B, C, so on, Z, or if you can use a capital letters A, B, C, so on, Z. If the language is not supports, it doesn't support uppercase letters, then we will take only lowercase letters. In general, alphanumeric symbols, it is any combination of alphabets. And numericals, what are the numericals? 0, 1, 2, 3, so on, 9. So, these are the available alphabets, available digits. Okay. What is a identifier? Any combination of alphabets and numericals. So, any combination of letters and any combination of digits. So, the combination of letters and digits L plus D whole star. The meaning of L plus D whole star means any combination of letter and digits. You can use only letters, you can use only digits, or you can use both the combination of letters and digits. The meaning of L plus D whole star, I will tell you. The meaning of x plus y whole star is it can give you only epsilon, or it can give you only x. X means only 2 times or 1 time or 3 times or 4 times, any number of x only, or any number of y's only. Y's you can take any number of times, maybe 1 time, 2 time, 3 time, 4 time, 100 time, or any combination of x and y. First take x, again x, then y, or then x, then y, anything, or start with y, again x, again y, like this. Any combination of x and y means you take x, y, y, or x, then y, or first y, then x, then x, whatever you using the combination of x and y, whatever the string you can write, that comes from x plus y whole star. The meaning of x plus y whole star is epsilon, only x, only y, any combination of x and y. So the meaning of L plus D, I think you got it, any combination of L and D. So but what is a identifier? The first symbol must be a letter. So the first symbol must be letter followed by a letter or digit combination. So this is the expression, this is the regular expression, for identifier. So how will you accept this one? We need a initial state. So even though you are not getting, just leave it. It is not at all it don't depends the future topics, the next topics won't depends on this part. Okay, if you are not getting anything, as you are absent for TOC, you just listen and leave it. If you are not getting, if you are getting, it's good. Okay, the first symbol must be letter, then followed by letter or digit, okay. And you remember, so it can be underscore also, na. So I write underscore also. So instead of this, you can write like this also, letter or digit or underscore. Similarly, the first symbol can be letter or underscore. So this is the regular expression. Okay, sorry, this is the finite automata. Or you can write like this. If you want to go for this, either letter, if the first symbol is letter, or if the first symbol can be underscore, then followed by letter or digit or underscore, the combination. Or you can copy like this also, or instead of doing separately, you can write like this also. That depends. Okay, we are not doing any minimized. So this is the regular expression and corresponding finite automata. It is recognition of identifier. An identifier in general, any combination of alpha numerics, the first symbol must be letter or underscore. So that is the reason, letter or underscore. Okay, if you want to, okay, I don't make it more confusion, so just copy this one. If you want more, I will write like this, letter or underscore followed by L plus D whole star. So you will misunderstand this. So that is the reason I am writing this one only. Okay. Guys, do you understand? Any doubt? So the first symbol can be letter. The first symbol can be letter, or letter means okay, alphabet, or it can be underscore also. Okay, this is letter or underscore. That is the reason I have. Then followed by letter or digit or underscore. So that is also arrayed here. Letter or digit or underscore. This is the complete regular expression for identifier. This is the perfect expression. This is the final expression. Done? Copied? Make it fast. So I will give you break at 1:15. Yeah, this is final one. This is the final one. Initially, I have not make it perfect because some of your friends joined yesterday only. They don't know complete about regular expression. That is the reason I have not given. But the final one is this. So this is the automata. Okay, next. Recognition of relational operators. Suppose there is a less than something. So less than followed by something. So it will be other something less than. Suppose less than or equal to less than or equal to. This is less than or equal to. Then followed by other. This is for less than. This is for less than or equal to. Suppose greater than. So this is greater than followed by something. So how to write the diagram for relational operators? Suppose it is greater than or equal to. This is greater than or equal to. Then for greater than or equal to, after that something. Suppose it is less than not equal to. That means you can go to less than, then greater than and followed by other. So these are the recognition of relational operators using finite automata. You can copy this. This is for greater than. This is for greater than. This is for greater than or equal to. This is for not equal to. This is for less than or equal to. This is for less than. Of course, I am not constructing the minimized DFA. You know well, this is not the minimized DFA. Okay. So this is about tokens and patterns and lexemes. Then we will go back. Copied. Make it fast, guys. Make it fast. So today after lunch, this topic will be completed in 1.5 hours to 2 hours, including the questions. So then I will give another break in the afternoon session. Then I will start the syntax analysis topic. So every Monday to Friday, the class timings are 6 to 10, and Saturday, Sunday you will have 8 hours of class. So next Saturday depends. If anybody has the college, then I can keep that class Saturday afternoon from 1 onwards, or if everybody is willing, morning 9 to 6. But Sunday is 9 to 6. Sunday timings are fixed 9 to 6. Only Saturday I can keep according to your wish, either 9 to 6 or 1 to 9. Depends. We will discuss after. Next. Okay, divides it into tokens. This part is done. Ignores comments. So actually, whenever you are writing a program, suppose there is a code and I wrote this statement. So here I write a comment to better understand, multiplying two numbers, like this I have written the comment. So this comment is not at all part of the program. That is for understanding whenever you revise the program, or if somebody else revise the program. Okay, then to better understanding we write the comments. So comment is not at all part of the program, then the comments will be ignored. So whatever you write the comment, this comment will be completely ignored. It won't divide. It won't divide anything into the tokens. The lexical analyzer won't divide the comment into tokens. Okay. Now have you observed here? You have opened the comment and you have closed the comment. After the comment, if you write anything, suppose C equal to some 10, then you see it. Until here, the lexical analyzer divided into tokens. This is token, A is a token, operator, identifier, then punctuation mark, and this part will be ignored. Then this is identifier, then operator, constant, punctuation mark. It will follows the next part, but only this part cannot be divided to token. So that is the meaning of ignores comments. So whenever a comment is there, example, and one more thing I tell you. A equal to B, then I am writing comment, this is the comment, and immediately C, the semicolon. Okay, there is no space anywhere. A equal to B, immediately followed by comment, closed with comment, immediately follows C, then semicolon. So here, if you give the white space, means blank space. So whenever white space comes, example, A, B, C, D, in between there is no space, then white space, then A, example. Whenever space is there, the space tells that until here it is one token, Whenever space comes, a space is there, that space indicates that next coming group of characters are different tokens from the previous one. So whenever space is there, then space will be ignored, ignore the spaces, ignore the white spaces, then next group of characters will be another token. So to separate this token and this token, we can use the blank space. Similarly, look at this. A is a token, this is identifier, this is operator, this is identifier. Have you observed? This is a comment. Comment will be ignored. When you ignore the comment, so the result of this one will be like this: A equal to B, even though immediately after forward slash, without gap, without space, if you write the C, after deleting this comment, it will be like this. So comment can be used as a separation of the tokens. So A is an identifier, this is operator, identifier, and this is different identifier. It is not like that. A equal to BC semicolon and BC is one token. No, B is one token, C is another token. So white space you can use it as a token separator. Okay. Now, so here the main point is the comments, whenever comments are there, comments won't be generated as a token. Comments won't be considered by lexical analyzer. Simply they will be ignored. Okay. Next, ignore white space characters. I told you, we ignore white space characters such as blank space, tab space, new line characters. It will be ignored by lexical analyzer. Next, count the number of lines in the source program. How many lines are there? That will be counted by lexical analyzer. Next, it creates the symbol table. Symbol table is a data structure which contains the information about the variables and attributes, function names, classes, objects, and the data structure used to implement the symbol table is, I think I have given linked list, insertion time, search time, and binary search tree, hash table. I think I have given you this one. And now, so this is done. It produces lexical errors with line number and column number if any. So what are the possible lexical errors and how to overcome? What are the error recovery methods? That we will see. With that, this part will be done. The lexical part will be completed. After this lexical error completion of this part, I will tell you what are the possible questions can come from this topic. From this topic, a code will be given. They will ask you whether lexical error is there or not. Consider the following C program. So what is the compiler response? Option A, lexical error, option B, syntax error, option D, semantic error. Like this they can ask you. Or consider the following C program and how many tokens will be produced by lexical analyzer. So they can ask you the number of tokens, or they can ask you the lexical error. So these kind of questions can come from this topic. Okay. So we have done tokens, pattern, lexemes, ignores comments, ignores white spaces, and count the number of lines, create the symbol table, and interacts with the syntax analyzer. Now the last part, it produces lexical errors if any. So what are the lexical errors? Shall I go? Any doubts, guys? Hello, dear students, any doubts? Priya Rani, how many tokens are there? Why are you asking about how many tokens? We will see. Okay, Praveen Kumar, printf total score. Okay, we will see that everything. Hey, dictate ignore comments. What should I dictate in the ignore comments? Comments, yeah, wherever you read the comment will be ignored. Simple. For this, what should I give the notes? Huh? So how many tokens? All these we will see later on. Number of tokens, number of errors. Okay. I will give the break at 1:15. 1:15. Lexical error. Lexical errors I have not completed till now. Tushar, I will do. Lexical error is not yet completed. Even I have not started yet. Okay. Next, lexical errors. Lexical errors. Okay. Whenever scanned group of characters is not matching with any of the rules of the tokens, then it will be thrown as a lexical error. I repeat. So lexical analyzer scans. So whatever it scans, if it is not matching with any of the rules, then it will be an error. Okay. So take lexical error. Whenever scanned group of characters is not matching with any of the rules of the tokens, then whenever it is not matching with any of the rules of the token, then a lexical error will be produced. So what are the lexical errors? Unterminated comments. Suppose A equal to B plus C into D something, okay, and you have written some comment. It is a multiple comment. So whenever you open // by star, whenever you have opened this part, the lexical analyzer will checks whether there is a star followed by / is present in the same line or after multiple lines. So whenever you write this, the lexical analyzer will checks for is there any star followed by / is present or not. If it is not present either this place or in this place or in this place or nowhere in the program, then it will throw a unterminated comment. So when you open, you have to close either in the same line or after some lines. If you don't close this one, if it is not there, then it will be a unterminated comment. So whenever you open the comment, you have to close it. Okay. Next, unmatched string. Hello, I don't give the notes for this. What is unterminated comment? And don't ask me again. Unmatched string. Okay. Suppose you have opened a double quotes. Okay. Compiler design. Okay. And double quotes. When double quotes are open, they must be closed. If it is not closed, it is unmatched string. If it is not present, then it is unmatched string. Then it will throw an error. Okay. I repeat, guys. So when you open double quotes, okay, you have to close it. If you don't close this, then it will throw a unmatched string. Now illegal characters present. So every language will have some allows only specified characters. If you are using any unspecified symbols, unspecified characters in the program, then it will be thrown as a illegal characters. Okay, as example, in the case of C language, it don't support @ you can check it. Okay, so I am not sure. So whatever the illegal symbols that is not supported by the corresponding language, then the lexical analyzer throw as a illegal characters present. Next, invalid identifier. invalid identifier. That means there are some rules for the identifier. If it is not follows the rules of the identifier, example, int a1, it is a valid. At the same time, int 1a, it is invalid. 1a, because the identifier is starting with a numerical value 1. So any identifier should not start with according to the rules of the C language. If some language, if they allow the numericals also in the starting, that is different story. Okay, so clearly every compiler purely depends on the programming language. And also depends on the machine. So okay, leave out the machine. We are talking about the language. So if a language supports starting a numerical, that is okay. If it is in general, if you take the C language, it don't support the identifier name in the starting a numerical value. So this is invalid identifier. Next, similarly, invalid constant. I am writing int a equal to 2.5. So int a equal to 2.5. If you consider this one, int is a keyword, a is an identifier, it is an operator, 2.5 is a constant, and it is a punctuation mark. There is no error. There is no lexical error. The lexical analyzer cannot check that a is a integer data type and it is assigned a float number. This cannot be done by lexical analyzer. This will be verified in semantic analysis phase. Are you following? Even though a is a integer data type, even though you are assigning a float number to variable a, that will not be thrown as error by lexical analyzer. So it is a valid. Everything will be divided into tokens. At the same time, int a equal to $10. If you are using a special symbol like this, then it will throw invalid constant. Got it? Invalid constant. Next. Exceeding the length of the identifier. Exceeding the length of the identifier. Exceeding the length of the identifier. So maximum length is 32 characters. If you exceeds beyond this, then it may go for it will go for a lexical error. Okay. So these are some possible errors that can be produced by lexical analysis. So unterminated comments, whenever you open, it has to be closed. Unmatched string, if you open double quotes, it has to be closed. And illegal character present, and invalid identifier, invalid constant, exceeding the length of the identifier, more than 32 characters, then it will be thrown an error. Okay, copy this one. Okay. Okay guys, so what are the different error recovery methods? And what are the there is a tool, Lex is a tool, Lex is a tool which can be used to generate the lexical analyzer. So what are the error recovery methods? What is a Lex tool? And questions? what are the lexical errors, what is the number of tokens, this all we do after the break. Okay. Once we complete all this, you can start the workbook. Okay, but today I don't do workbook, I will start the syntax analyzer. So workbook I upload tomorrow. Okay, take a break. Now it is my time is, it is 1:20, so you come back at 2 o'clock.